Welcome back to Remote Sensing Applications using ArcGIS. In this session, we're going to look at the change in the Normalized Difference Vegetation Index from 1986 to 2009 along the haul road in the Arctic of Alaska. So here's an image that you can download with this week's data from 1986. And it's Landsat thematic mapper bands 2, 3, 4, and 5. So band 2 is the green spectral region, band 3 is the red spectral region, band 4 near infrared, and band 5 is the shortwave infrared. So if we go to symbology, we'll symbolize this 1986 raster, which was from July 6th, as a color infrared image. So that will be bands, the near-infrared spectral region to control the red video intensity, the red spectral region to control the green video intensity, and the green spectral region to control the blue video intensity. And we'll use a 1 standard deviation contrast stretch, and then just OK. So here's the haul road, and here's the Trans-Alaskan pipeline. And I've buffered the haul road by 10 kilometers and then clipped this scene to that buffer. So if we look at zoom to layer the entire area, here's sort of the coastal plain and then the Arctic foothills. And it's within 10 kilometers of the haul road. And then we'll do the same thing. We'll symbolize the 2009 raster using the same symbology. So if I go to properties, this raster is bands 2, 3, 4, and 5 from Landsat thematic mapper, July 5th, 2009. So then under symbology, we'll import it from our 1986 raster. Okay, so as an example, here we have the color infrared image from July 6, 1986, and here we have the same area from July 5th, 2009. And you can see that we do have an increase in shrub in many of the riparian areas. Okay, if you look at our 2009 image, there's some low fog occurring along the coastal plain. So what we'll do is we'll create a mask to mask out these pixels that are low fog pixels. So to do that, we'll use the thermal band, band 6. So here's the thermal band in band 6, and you can see that these foggy areas were cool pixels. So what we'll do is we'll use the threshold, a value of 120 as our threshold. So any pixel that has a value less than 120, we're going to consider it to be a cold pixel that's either fog contaminated or it's a cold water pixel. So we'll use the con tool to create our mask. So if the pixel value is above 120, it's a warm enough pixel. We'll keep it as a value 1. If it's less than or equal to 120, it's too cold, so it'll become no data. And we'll output this to a raster called mask coldpixel.tiff, and then just OK. And then we'll use symbology to make all those warm pixels no transparent, and all the no data pixels will give it some cold color. So I'll make them white, for example, and then just OK. So there we have our mask. So here's our 2009 color infrared image, and then we mask out all the cold pixels. So anything in white in this example is masked out as being a cold pixel. Okay, our next step is to isolate those pixels that have an NDVI value representing vegetated pixels. So we'll use a threshold in this example. It's a scaled NDVI, so normally NDVI ranges from -1 to +1, but that would be a floating point value. So here we just scaled it, so a 3000 would be an NDVI of 0.3. So if we have an NDVI above 3000, we're going to consider that a vegetated pixel, and we'll keep the NDVI value. And then we'll output that to veg NDVI 1986, but what we want to do is exclude those cold pixels that we set as our mask. So if you go to environments, under raster analysis, set your mask to our mask cold pixels.tiff, and then OK. So the result is NDVI for all those pixels that have values above 3000, and we've masked out those cold fog contaminated pixels or those cold pixels that are water pixels. And then we repeat the process for our 2009 NDVI raster. So once again, the question is the NDVI value above 3000? And if it is, keep that NDVI value. If it's not, make the pixel no data. And we'll output that to a raster veg NDVI 2009.tiff. And then once again, we need to set our mask. So under environments, and then raster analysis, our mask should be set to mask cold pixels.tiff, and then just OK and OK. Okay, so here are all the pixels that had an NDVI above 3000 in 1986, symbolized using a color ramp, and here's the same area using the same color ramp in 2009. So you can see that in general we've got a change in NDVI. So the next step will be we'll subtract the 1986 NDVI from the 2009 NDVI. So you could use the raster calculator, or you can use the minus tool. So I use the minus geoprocessing tool. So take the vegetated NDVI from 2009, minus it from the vegetation NDVI in 1986, and that will create a new raster, veg NDVI from 1986 to 2009. So negative values will represent pixels that had a declining NDVI. Positive values will represent pixels that had an increase in NDVI from 1986 to 2009. And then just OK. Okay, so then what we'll do is go to symbology, and then we want to classify, and we'll classify based on standard deviation. So the mean plus or minus a standard deviation, and here we'll go plus or minus 1 standard deviation. So you notice from this histogram we've got a bell-shaped curve, and on average we had an increase in NDVI of about 204. So most of our pixels will have an increase in NDVI, and then just OK, and then we'll give it some color ramp. So we'll do a green color ramp. And what we're really interested in is the high levels. So we'll change the highest one to a very dark green, and then the next to the highest one to another dark green. And then these we'll make transparent, so no color for anything that's negative. And then just OK. So here we've got an increase in NDVI, especially along the river. So for example, we'll zoom in on this area. So here's what it looked like in 1986. And then here's the color infrared image from 2009. So you see there's a dramatic increase in shrub in this area. Okay, so if you go to the Blackboard website, I've got some quiz questions for you concerning this exercise.